Hey guys, so this is 5.5 in Algebra 2, and in terms of 5.5, 5.6, and 5.7, this video that we're doing right now is probably the most important conceptually. It helps us understand what we're doing and why it's happening. Okay. After this, it's just, hey, how do we get to the answer, and we're going to be as efficient as we can. But this is going to help us understand how and why things are the way they are. We actually have to start with something like let's say 107 divided by 3. Okay, this is back to elementary school when we learned how to do long division. And that's going to be how this kind of starts out. We ask, does the 3 go into the 1? The answer is no. So then does the 3 go into the 10? The answer is yes, it goes in 3 times. And so now that we know that it's 3, we're going to multiply by 3, right? We times that value down. 3 times 3 produces a 9. But then I don't add the 10 and 9. I always subtract what I just created. So 10 take away the 9 is 1. And I bring down the 7. And I ask again, does 3 go into 17? The answer is yes, it goes in 5 times. And now I take that 5 times the 3 to produce a 15. Now hopefully, and then again I subtract and I get 2. Now hopefully this is somewhat familiar to you because the sequence and the arithmetic we're using here is going to be really important for the first few questions that you go through in your homework. This long division process. Now there were 2 ways to handle things like this. If that 2, if we asked that decimals were acceptable, we would, put a decimal, extend by adding zeros, and continue on until we got either a repeating decimal or we got a terminating decimal. That's great, but in this, we're not going to do that with polynomials. We're going to just use remainders. And so you could think about it as we'd say we'd have a remainder of 2, right? That'd be my remainder. And so we could write this as a mixed number, saying that it's 35, and the remainder is 2 over what we're dividing by 3. So 3 goes into 107, 35 and 2/3 times. What this means is that if I take 3 times 35 and 2/3, I will get 107. The key here, guys, is that we're taking something like 107 and we're creating a multiplication problem out of its parts. That's our goal for 5.5, 5.6, and 5.7, is division to break it into parts. And here's the conceptual reason why. X squared plus 5x plus 6 equal to 0. If we think about this polynomial, it's quadratic. It would look something like that. It's not perfect. Finding these 2 points is not inherently obvious, okay, by looking at this equation here. However, when it's factored into a multiplication problem, see, we're thinking multiplication problem. When we create a multiplication problem of x plus 2 and x plus 3 equal to 0, it becomes obvious that negative 2 and negative 3 are solutions. So what we're trying to do through the next 3 sections is create multiplication problems by using division in order to help factor problems. I want this version here, and the only way I'm going to get that version is by using some sort of division to get there. All right, let's see if we can let's see if we can clear the screen for us and talk about how it looks when it's a polynomial, because this was all great for simple numbers that we learned about back in elementary school. But what happens when it's an x squared and that kind of stuff? So we're going to go through this through the long division, and then we'll talk about what's called synthetic division. Okay, the first few problems in your assignment ask you to do long division. So you'll have something like x cubed plus 3x squared minus 5x plus 8, and we want to divide that by x minus, say, 2. We want to use the same rules that we used in long division in elementary school. I'm going to put the x cubed here, plus 3x squared, minus 5x, and add 8. And I want to divide that by x minus 2. Okay, there's my setup. Just putting the big thing in the square inside the division, and then having my x minus 2 on the outside. The difference here is that because it's x minus 2, it's not x, we're going to have a little bit more work to do as we're trying to go through this process. So if we look at this, we've got an x. I know that I'm going to eventually subtract down here, right? I'm going to put something down here and I'm going to minus. I would really love this x cubed to go away. So the question is, how do we turn this first x here into an x cubed? You know, how many times does x go into x cubed? The answer is x squared. Here's how I know that. When I take x squared times x, I get exactly x cubed. I want these two right here to match. They have to be perfect partners. That's going to allow me to cancel the x cubed here in just a minute. That's going to be perfect for moving forward in the problem. However, when I multiply that x squared, I have to also multiply it by the negative 2. We have to distribute. It's a parentheses. It's a group of things. So x squared times the negative 2 is negative 2x squared. Now you're probably thinking, Mr. Welch, sure, the x cubed cancels, but this thing over here, the 3x squared and the negative 2x squared, they're not going to cancel. And that's okay. We're just trying to take off the first term every time. Now remember, when I had that 10 and I brought the 9 down, I subtracted the 9. This line right here needs to be subtracted. So we are going to, I'm going to grab a different color. We are going to change the signs via the subtraction. Subtraction through a line would, like we did the distribution on 5-3, we distribute the negative. Well, think of distributing the negative through this bottom line here. We'll see that x cubed minus x cubed does cancel. That's what I needed. Now, I have 3x squared plus 2x squared for 5x squared, and I will bring down one more term. You could bring all of it down if you want. We're only going to be working 2 terms at a time. So now we're going green. How do I make this x be a 5x squared? That's what I'm shooting for, this guy right there. He's the one I got to get rid of. Well, x goes into 5x squared 5x times, and that'd be positive 5x. I know that that's correct because when I multiply 5x times x, it produces the exact same 5x squared that I have above it. And then that 5x times a negative 2 would produce a negative 10x. But remember, we never add these the way they are because the 5x squared doesn't cancel 5x squared unless it's negative. So we subtract this line. Subtract means to change all of the signs. I use a different color or do something very elaborate to make sure that you know that I'm canceling this negative to make it a positive. Here the 5x squareds do cancel, and negative 5x plus 10x is a positive 5x. I'm going to bring the 8 down, plus 8. And I'm going to ask yet again, how do I turn x into a 5x? Well, that would just need a 5. So plus 5, and if I multiply that through, it produces 5x, and 5 times negative 2 would be negative 10. But don't forget, when we do this line, we're going to subtract it, which changes all the signs. My 5x's cancel, and I have 8 plus 10 for 18. Now, can you turn an x into an 18? The answer is no. We need an x in that 18 in order to be able to do anything with it. So this would be my remainder. So, to put that into my answer, I am going to add whatever this number is. Okay, 18 over whatever I was trying to divide by. Just like we did the 2 over 3, this is the same 18 over x minus 2. This is the long division, okay, of this problem. Now, Here's the deal. This is a mess. If we're really honest, it's a disaster. There are problems in polynomials that cannot be done any other way but long division. And so on the assignment, I think it's 3, 4, and 5, something like that, the first few questions I ask you to attempt to get through this long division process and try to reason through it. However, we learned something a couple of days ago back in 5.2 that opened up a door. We didn't know what door it opened. I didn't really talk about it, but it actually comes into play here. If you remember doing synthetic substitution, it actually has a very, very useful application in division. So we're going to switch it from synthetic substitution to synthetic division. Okay, we're going to build it just like we did last time. Okay, a couple things. We've got x cubed plus 3x squared minus 5x plus 8. So I'm going to use a 1 for my x cubed, 3 for my x squared, negative 5 for my x, and a positive 8 for my constant. One thing that gets people messed up all the time, we're dividing by x minus 2. Now, we need a bouncer, right? Well, it's going to come out of this parentheses and get dumped right here. But we said something early in the year that we still have to hold to, which is that whenever we want to pull a number out of a grouping with x, right? This is in the parentheses with the x, we're going to have to do a sign switch because we want to know what makes this 0. Well, it turns out that it's 2. Okay? So now, instead of using a negative 2, I use a positive 2, all right? So now we're going to run through the synthetic division, and you're going to tell me what you see in your answer at the end of this. We bring the first number, always comes straight down. To get back in, we times by our bouncer, which is 2. 1 times 2 is 2. We always add to get out. 3 plus 2 is 5. 5 times 2 is 10. Negative 5 plus 10 is 5. 5 times 2 is 10. And 8 plus 10 is 18. Now, if you look really closely at this sequence of numbers, and you look real closely at this sequence of numbers here, you should see something. You should see a 1, followed by a 5, followed by a 5, and last by an 18. I mean, boom, mind blown, okay? Let's be honest. This is, wait, what? We just did, in about 30 seconds, what takes a lot of thought and a lot of effort if we're doing it by long division. This is a big deal. What we have to remember is that every time we do a division, the exponent, x cubed, right, is going to drop 1. So instead of being x cubed, it's now x squared. After x squared comes regular x. Last would be our constant. See how this has a bar underneath it? It's almost like it's saying this is a fraction. That's exactly right. We get 18 over whatever we were dividing by, which is x minus 2. That is pretty slick. So that's synthetic division in its just pure raw form. And it's going to save us a bunch of time. I know this video is going a little long, but just stay with me. It's worth it. Here's the deal. I don't really want to split numbers when I factor them with remainders. Like, remainders are a problem. Think about it. When I say, does 25 divide by 3, we say no, because there's a remainder. We don't want the remainder of 1 or the extra 1/3. Even though it's physically possible, we say, it's not worth it. We want to divide by things that come out nice. Like 25, it'd be much better to divide it by 5 because it goes in evenly. And that's what we're going to focus on in the second half of 5.5 and then into 5.6 and 5.7. We're going to be looking for perfect divisions. All right, so let's see what we can do with this stuff. Oops. Okay, so we're going to do the perfect kinds of division, the stuff that actually factors down, and talk about what the purpose of all of this is. So let's imagine that we had x squared minus 2, sorry, x cubed minus 2x squared, there we go, minus x plus 2. All right. If I were to tell you that it factors, okay, so I'm going to divide it by x minus 1. I'm claiming that this divides nicely. Okay, so let's talk about what that looks like as we go through the synthetic division. Something special is going to happen. Okay, we're going to put a positive 1 there. That's my bouncer, right? Boom. He drops in as a 1. My numbers would be 1 for x cubed, minus 2 for x squared, minus 1 for x, and positive 2 for my constant. Okay, so we're going to run through the synthetic division. The 1 drops down. 1 times 1 is 1. Negative 2 plus 1 is negative 1. Negative 1 times 1 is negative 1. Negative 1 plus negative 1 is negative 2. And 1 times negative 2 is negative 2. My remainder is 0. What this means is that x cubed minus 2x squared minus x plus 2 is the same thing as my x minus 1 that I just divided off times x squared x. And that'd be my constant. So x squared minus x minus 2. This is a perfect factor. No remainder, so it's just that times what's remaining. Now, remember our goal was to try and figure out where a polynomial crosses the x-axis, these points here. That's what we're always focused on. Well, I know that it crosses at a positive 1 because that is one of its factors. So if I set this equal to 0, I'd have one of my answers. But it goes further still because now this x squared minus x minus 2 might be factorable. And if it's not, there's the quadratic formula. I can solve a quadratic, an x squared equation, whereas x cubed was too much. Now I've broken it down to a smaller level where I should be able to factor it off, which this would split as x and x. What are the factors of 2 that subtract to 1? Well, that'd be 2 and 1, the only choices. The 2 is negative, so my signs are different. To get a negative 1, I would need negative 2 and plus 1. X minus 1. So this right here is the factored version of the original equation. They are the same thing. If I were to graph both of them, they would look identical in every way. The difference is that here I can tell that it has zeros, or crosses the x-axis, at positive 1, positive 2, and negative 1. I have information that I couldn't have gotten any other way. This synthetic division is going to give us such useful information. As you go through your homework, just kind of run you through it real quick here in 5.5. Sorry, the video I know is long. Okay, first you're going to do long division, where you try that really nasty looking long division. Then synthetic division, where we divide. You're still going to have remainders here. That's not going to go to 0, okay? As a side note, do you see like number 14 here? It has the x squared, but doesn't have the x. That means you're going to have a 0 inserted whenever something's missing. So this equation here, the synthetic, would be 1, 0, 9. Okay, number 15, you have x cubed, x squared, but not x. So that'd be 1, negative 5, 0, negative 2 as you run your numbers across the top. Okay, down here, factor completely. Okay, so when it says factor completely, instead of giving zeros, so factor completely is when our answers look like this box right here. This right here. Whoops, sorry. This is factor completely. Okay, so factor completely, we want them to be in parentheses. When it gives us a 0 and asks for other zeros, guys, this negative 3 is the bouncer. Okay, it's one of the values. It's not with x. So it's already a 0. They're telling us that it's one of them, and we want to know what the others are. There's 2 more. That's how you'll finish. That's how we finish this last problem here, when we give all of the zeros in their individual numeric form, okay? So those are the 2 different types of problems at the end there. If you have questions, watch the other video with the homework help, or reach out to me and we can talk about it when we see each other in class. Good luck. Sorry for the long video, but this is foundational to everything we're doing in 5.6 and 5.7. So good luck, and we'll see you in class.